So this team combines expertise in robotics, neuroscience, and moral philosophy to really answer questions about how ought robots to behave, develop an ethical framework for robots. I mean, we've seen upstream of this presentation how challenging it is to think about how we ourselves should behave and how to get us human beings to behave the right way. Is it easier or more difficult to do that with robots? Let's find out.
It's that time, Dave Handelman. Excuse me, Dave Handelman. I'm a senior roboticist at the Applied Physics Lab. Thrilled to be here. I want to thank Mariah and the Berman Institute for funding this. Our project is called Ethical Robotics Implementing Value-Driven Behavior in Autonomous Systems. So the team is amazing. Deborah Matthews, Travis Rieder, Ariel Greenberg, you'll hear from them, and then Julie Marble and Bruce Sweat at APL are helping as well. So we're going to do a tag team here. I'm going to try to go really quickly. Why are we here? I won't go through the slide, but our machines are getting smarter. You have phones that you're carrying with computers that have capabilities that we never imagined 20 years ago. So our machines are getting smarter, including, we heard about autonomous vehicles and also robotics. So I'm going to quickly show you some of the robotics work we're doing at APL to lead into sort of a state-of-the-art argument. Sorry, I got to get to the desktop here. So at APL, we're interested in autonomous vehicles and aircraft, et cetera, but also robotics. And so I wanted to introduce kind of where we're coming from in terms of a use case that we're using to investigate applying potentially moral decision-making and ethical decision-making to machines. So this is a modular prosthetic limb you see here. We help with DARPA funding. The intent is to help wounded warriors get functionality back. It's a very human-like manipulator. This is Robo Sally. She has 2 arms that have these modular prosthetic limbs. So we use them for prosthetics and robotics. And we're starting to enable, and this is remotely controlled. So I'll show you a little bit of autonomy. So we care about the whole autonomy spectrum, directly controlling the machine remotely potentially, but also making them smart enough to do things on their own. It's the latter we most care about here. But these are the types of tasks we're trying to enable. So again, here's a scenario. This is sped up, but 2 robots doing a casualty evacuation scenario where applying a collar to a dummy, removing rubble, putting on a spine board, and getting it out of harm's way. So the point here is we're trying. So that's a trauma care example. We're trying to look at situations where you need mobility and dexterity in a remote robot, and then there are situations, obviously, where you're going to get into ethical considerations. So I'll pass it over to Travis to get into some of the concepts we're talking about.
So all of the conceptual work in this project in 3 minutes go. Okay. So I'm speaking about Deborah Matthews and I, part of the project, which is basically trying to figure out what is the philosophy and science policy that we need to do to interface with these guys who are actually on the ground making robots that do really cool and sometimes scary things. So what's the feature that Dave was talking about that's kind of most interesting? Robots, once upon a time, weren't all that interesting ethically, because robot ethics, were we to call such a thing, were we to say such a thing, would be like engineering ethics, like ethics about the individuals doing the creation. Now, robots have decision points, and that's newish, right? And it's getting more and more so. So the basic idea is when the property of semi-autonomy is included in a robot or in a system, that is then able to choose futures among some restricted set usually. But for the sake of usability, our plan is, and most roboticists hope is, that our robots will actually get better at making more decisions without consulting a human controller every time. So if you're an ethicist, what you're thinking is, cool, but also terrifying, right? Because now the ethics looks different, because the thing doing the deciding, and I know that sounds anthropomorphic, that may be more or less appropriate as science develops, but the thing doing the deciding is no longer the human controller. The robot is itself making a decision without checking back. So that's why robot ethics, or the ethics of semi-autonomous systems, introduces something new. We've had semi-autonomous systems in the world. We heard in the autonomous vehicles this discussion about planes before, and now cars. So autopilot systems have this limited scope of autonomy. But we're thinking, okay, in the future, we're hoping there might be companion robots, or say elder care robots, living in your house and helping you to do things. So if you say, hey robot, can you please go make me a coffee and bring me a cup? And it has latitude to determine how to discharge that responsibility. Well, so you might want it to do a whole bunch of things because it's in close proximity to you. And one of them might be like not step on the baby crawling around on the floor as it goes to make you a coffee. And that capability, it turns out, is really, really difficult to think about how to program into a robot. So our project started with Asimov. Everybody's read Asimov, I hope, right? So there's great science fiction, 3 laws of robotics. And so we actually decided that for all sorts of reasons that we can talk about during Q&A if you want, Deborah and I spent the year kind of thinking through what's been done in robot ethics so far, and we decided that these guys were interested in Asimov as roboticists. It's not a terrible place to start. And the reason was something like, eventually, as robots get kind of rolled out and broader, with more autonomy more broadly, we're going to want the values that restrict the robots to be decided in terms of some kind of public engagement. I'll point to Deborah here because that's her stuff, not mine. But we need a first step, and so our pragmatic first step in doing this sort of thing is, Asimov didn't have half bad idea. First half of the first principle, can we get the robot not to step on the kid crawling on the floor? Can we program a principle of non-maleficence into a semi-autonomous system? And Ariel's going to tell us if that's possible.
Wait, what's non-maleficence?
Non-maleficence, do no harm. Yes, good call.
Awesome, thank you. So between the part where Travis sets up the pins and David knocks them down, I'm going to tell you a bit about a bridge between, oh, there we go. The bridge between that philosophical back end and the ultimate actuation of all that. So we described starting point of Asimov's laws. I'm going to speak about the first clause of the first law here and talk a little bit about how we go about implementing that. First, just as a caveat, we do recognize these were developed for narrative purpose, but as Travis described, it's not a bad starting point. So, or at least you could do worse. So the first half of the first law, a robot may not injure a human being. Okay, so that's something that's very accessible to us. But for a machine to understand that, let's talk about a few of the things it needs to understand as constituents. So what is a human being? How is a human being injured? And what is injurious to a human being? All these are not readily accessible to a human, to a robot who's about to make these autonomous decisions. And furthermore, they entail all these perceptual and reasoning capabilities that we aren't there yet with. So we began with an approach to implementing this. Has these 3 stages described here. In total, we call moral scene assessment. First step is to identify what within the scene is morally salient. So what are the minds, the minded entities in the scene, and the objects in the scene that relate to those minds. And then once you know that, you can start thinking about how to interact with those entities differentially. Then we get to the final step here, which is to reason over injuries and insults that cause those injuries. I'll tell you a little bit about the first half of this, and then you'll see it in action with Dave's part. I recognize it's a bit blurry here, but over to on the right panel, you see what we have as in a computer vision system. We have this means zero-shot learning, it's called, and this is able to do, instead of direct object recognition, it pulls attributes off of objects. These attributes are very useful for making these kinds of determinations, like what is a mind and what is an object that is of affordance or danger to that mind. I see we're starting to flash here, so I'll get moving. We're able to do this and identify that Dave here in the scene is a minded entity and can be the recipient of moral action. You can do things to him. When you cut him, he bleeds and hurts, and we want to avoid that. Here you see the teddy bear. The teddy bear is of affordance to a moral patient, one who is the recipient of a moral action. And in this case, we're able to take these attributes off of the scene, identify minds, identify that which is of affordance or danger to those minds, and then learn how to interact with them, and then reason over how they may be injured and how one might avoid them being injured. Then I'll leave the videos.
Great. So ultimately, what we want to do is take concepts in ethics, translate that into a framework for autonomous systems. So we didn't get as far as doing that, but we'll show you some use cases and steps in that direction. We want the system to be autonomous. Here's, Ariel talked about perception. We want the system to extend its current capabilities and start detecting minds and things that might hold moral agents, moral patients. This is an example of the robot not doing that yet, but where we're headed in terms of the ability to recognize objects. He showed a two-dimensional case. This is a three-dimensional case. The green is the robot's understanding of where things are in the world. And if you're going to impact the world, you need to know where things are. This is an example of an autonomous behavior where we give the robot a very high-level description, and the robot can execute a task. So we're going to go back now to remotely control robots, but scenarios we want to get to where this is automatic. Okay, so here's a situation of picking and placing a sharp object. What we want to do is bring in the harm ontology. Toolboxes can't feel pain. People can. So if you're handing a sharp object, if my kid was handing a sharp object, and he or she did it pointy end first, I'd say, wait a minute, there are other ways to hand things over, and here's why. People can bleed, here are other ways to hand it. So here are two scenarios where the robot, being remotely controlled, is going to place a tool in a toolbox which can't feel harm itself. It can be damaged but not feel harm, be injured. But there are, even for this simple type of task, there are ways you might want to do it and ways you might not. And upper left, dangerous. It's leaving the blade exposed, and someone wanting to go get that tool might hurt themselves. On the bottom right is a safer way of doing it. And here's the same thing, just sped up a little bit. So the point is, we're trying to, what we didn't have time to show you is this ontology that we're building up and trying to translate into perception and action on the part of the robot. But even for just putting tools in a tool bin, there are different ways you want to do it, and we were trying to build into a framework a way of allowing the machine to distinguish who might be harmed and who might not be harmed and act accordingly. Here's a situation where we have a simulated person, and we have three different ways of doing it. First, on the bottom, you see the safest way is that as soon as the robot grabbed the tool, it moved, it turned the blade away. And the upper two, more dangerous way, it's brandishing that tool, almost like a weapon, okay? And I had somebody in the lab say, Dave, what are you doing? That's freaky, man. So, everybody gets it. This is a dangerous way to do things. And in the upper left, you see, that's not the way to handle it. This is a sharp saw. And so the dangerous way is obvious. The safer way, the tool is still being brandished in the upper right. Even though the terminal condition is safer, you still may not want to brandish the weapon. So we're trying to show a gradation of doing a task. The bottom one is the safest, where it's always pointing away from the user, and the tool is handled first. So the point here is we're trying to go from concepts in morality and ethics, translating that in the first case in terms of harm ontologies, and then actually have the robot start to do things that exercise that framework as an instantiation of how we might generalize it to other problems. So that's what we're trying to do, and that concludes our discussion.